Okay, so today we're going to talk about pediatric and adult dosage based on body weight. So a lot of times whenever we are given an order and it's based on our body weight, we're going to have to look at the recommendation to make sure the order meets that specific patient. Because if we get in a room full of people and we was to check everybody's amount, it would be different because it is based on our body weight. So let's get started. Let me get my pen going. All right, so we have this order. It says it's 1.8 milligrams intramuscular stat. And it says we have a patient who weighs 79 pounds. And then when we look at the drug reference or drug resource indicated, it could be, say, recommendation. There's multiple wordings that could be said there. For this specific drug. It does say intramuscular or subcute. So intramuscular, it means that. And it says that it has a maximum amount of 0.05 milligrams per kilogram per dose. Wants to know, is it safe? Because if it's not safe, we cannot administer the order. So what we're going to do is we're going to take our patient at 79 pounds and we can convert it. And by doing that, we know that there is 2.2 pounds per kilogram. Now, some of you are going to want to do this separate. Just remember when you do this separately, if you get a decimal number, so I'm just saying, for example, it was this, this, and this, we got to be careful. We don't want to round too soon because we are talking about what's safe for this patient. However, if you are literally just asked, how much does this patient weigh in kilograms? Well, we know we're going to round to the nearest tenths, right? So I'm going to erase this. You could do one long conversion if you wanted to, or we could just do it in parts. Some people likes it in parts. It doesn't matter to me as long as you got your setup right and you do your math right, your answer is going to be right. In this one here, it's going to give me 35.9090 9. I'm going to round right here. Now, this is where I was talking about. If you were asked to state what does this patient weighs in kilograms, we would have said 35.9 kilograms. So there was no question about that. It just wants to know if the order is safe. So I'm going to leave all these digits and I'm going to apply the recommendation to it. So that means I'm going to multiply that by 0.05 milligrams over kilograms per dose. And I'm that visual person that I'm going to put one patient underneath this. You do not have to. If you don't need that, don't apply. To me, it's neater and it's less messy. So now we're going to go through here and I'm going to mark out the kilograms because they reduce, right? It leaves me milligrams per dose is what we want. And now I'm going to multiply. So I got 35.90909. I'm going to round to that placement. Okay, 1. So 91 times 0.0 or 0.05. And that gives me 1.7954. Oops, guys, I'm my pen. Got to get my word a little closer. And round it here. However, we know that's not our final answer. So what we're going to do is round, since it is milligrams, and we're going to look at it, it is intramuscular, so that's an injection, right? And if it's and also it should state in here as well, it's an injection. So whenever it's greater than 1, we know we round to the nearest tenths. So if we round to the nearest tenths, we get 1.8 milligrams per dose. So now let's determine if this order is safe. Well, the order is safe if and only if, I'm going to erase this up here. Order is safe if and only if the order is equal to or less than the maximum recommendation. All right, so what's recommended for this patient is 1.8 milligrams per dose, and the order is 1.8 milligrams. So yes, order is safe because it did not exceed the max. Exceed the, I probably left the E out, sorry guys. Did not exceed the maximum recommendation for this patient. Remember, we all have a different amount, so we all weigh something different for this patient. All right. So now, since it's safe, let's calculate what they're going to actually administer. So the order is 1.8 milligrams. Our supply is 5 milligrams per 1 milliliter. So that means we're going to take 1.8 divided by 5, and we get 0.36 milliliters. And guys, I have said something I shouldn't have said a while ago. I was correct. If it's an injection, you round to the nearest tenths because it's greater than 1. But however, we was actually just looking at the strength. So I'm going to do some erasing. I hope you already got this written down. Let me erase this around this. So I misspoke here, and I just realized it. So whenever, I mean, the statement's correct. There's nothing wrong with the statement. Don't erase that. That's correct. I just wanted to give myself some room. This here, when I said that we round to the nearest tenths because it was an injection and it's greater than 1, that is a true statement. But when we're finding the recommendation, we were actually looking at the strength, which is in milligrams, and it's not talking about the injection part. So if we were just looking for the actual recommendation, we look at the nearest hundreds. We're going to round to the nearest hundreds. And when I do that, I looked at the number behind it, which is a 5, which causes the 9 to go up to 10, which adds a 1 to the 7, which gave me the 1.8. So I apologize, I misspoke on that part. The part that we need to focus on the rounding is here when we're actually calculating how much we're going to administer. So make sure on the recommendation part, we round to the nearest hundreds. On the actual injection, the actual medicine you're going to give, round to whatever the rule says. If it's less than 1, it's the nearest hundreds. If it's greater than 1, then it's the nearest tenths. Okay. So let's move on to, so it's still safe. That's why we was able to calculate how much we're going to administer. So let's do our next one. Our next one here says we have a order of 20 milligrams intramuscular every 4 hours as needed for nausea for a patient that weighs 44 pounds. Now the drug resource, drug reference, the recommendation from the manufacturer states that it is for intramuscular, and it says that it has a minimum of 0.5 to a maximum of 1 milligram per kilogram per dose. Okay, so now we're going to have 2 columns. We're going to have a minimum column and a maximum column. So my minimum column, let's do that one first. And let's change this to a little bit thinner. All right. Well, we have this patient who is 44 pounds. If you wanted to, you can come over here and see if it gives you a clean decimal. I mean, not a clean decimal, but a clean number. So I know that in 2.2 pounds, that is 1 kilogram. So that means 44 divided by 2.2 gives me 20. So that was a clean number. So there's no worrying about if we rounded or not. I'm going to take the patient, write my notation a little better. I'm going to put it over 1 just because it's neater for me. Okay, so the minimum is 0.5 milligrams per kilogram per dose. So now I have 20 times 5, which is 100, or sorry. All right. Yes, 20 times 5, which is 100 milligrams per dose. So that's my minimum. So let's come over here and do our maximum. All right. Change that to this one. All right. So I'm going to take the 20 kilograms per one patient, multiply it by the maximum, which is 1 milligram per kilogram per dose. So 20 times 1 gives me 20 milligrams per dose. So that's my maximum. So how do we know if this order is safe? Well, what ago we just had a maximum. We didn't have a minimum and a max, but this time we do. We have both. So what we would have to do is, I'm going to set it up right quick. We have our recommended minimum is less than or equal to our order, less than or equal to our recommended max. Now, if our order falls between the recommended minimum and the recommended max, it's safe. If our order equals the minimum or the maximum of the recommendation, that's safe. However, when it becomes not safe is when the order falls below the recommended minimum. This means that not effective, right? Means they're not getting enough medication. So they're not getting well. So that leads to problems. If it falls higher than the recommended max, then it's an overdose. We're giving them too much medicine. So that's why I said if it fell between the minimum and maximum, it's safe. If it equaled either one of them, it's safe. So is this safe? Well, let's look at what we got. We have our order, which is 20 milligrams. We have our, y'all, no one, I just now caught that. On our minimum, it was 0.5 and not 5. So it is 10. So that's another way you can catch your mistakes. If your minimum was greater than your maximum, then you know you did something wrong. So these are little things you can look for. And I apologize, it was 0.5. So those of you that caught it, kudos to you. So the minimum is 10 milligrams. That's the recommendation at a minimum amount for this patient. And then we have a maximum amount for this patient is 20 milligrams. So yeah, this order is safe because it equaled the maximum. So it stayed within the guidelines. So since it's safe, yes, order is safe. Then we are going to calculate. I'm going to take my order, which is 20 milligrams, right? My order, and I'm going to divide it by the strength of my supply times the quantity of my supply. Of course, the milligrams reduce, and now I have 20 divided by 50, which is 2 divided by 5, gives me 0.4 milliliters. So that's what you'll administer to your patient. Okay, so let's move on just a little bit. we could do number 3. I feel confident that you are going to be able to do a lot of these, so I'm not going to work every one of them. I will skip some. So let's do number 3. Number 3 says that we have an order of 480 milligrams by mouth every 4 hours as needed for temperatures 101.6 degrees Fahrenheit or greater. We have a child who's 32 kilograms. So the child's weight's already calculated for you. We have a recommendation for childs that are for child dosage. We have a minimum of 10 to a maximum of 15 milligrams per dose by mouth every 4 hours as needed for fever. So we're going to have 2 columns. So we're going to have a minimum and we're going to have a maximum. So let's calculate it. Our patient is 32 kilograms times our minimum of 10 milligrams per kilogram per dose. So now I have 32 times that 10, which gives me what, 320 milligrams per dose. So that's my minimum. My maximum, so we have our 32 kilogram patient times my 15 milligrams per kilogram per dose. So now I have 32 times 15 is 480. So I did my math right? Because the maximum is greater than the minimum. And now let's determine, is the order safe? Well, the order is 480 milligrams. It is greater than the 320, but it equaled the maximum. So yes, the order is safe. All right, so now here is our supply. Let's figure out how much you're going to administer. So I'm going to take my order. And guys, the order is not always going to equal the maximum or minimum. A lot of times they'll fall between. So I'm going to take my order, divide it by the strength of the supply times the quantity of the supply. And now I got 480 divided by 160. And then I'm going to multiply that by 5. So it says 15 milliliters is what we will administer.